I'm Joshua Wyanju, and this is Quick Math. Today I'll be doing matrices, as I mentioned in my last video. Today it will be a shorter one than the previous one. I will just be briefly going over how matrices can be used to solve linear equations, the basic functions that you can use when you're doing matrices. And that's about it. In the next video, I'll be doing determinants, and the next video, I have a special topic, the golden ratio. You'll find out what that is in the next video. So, let's begin. So, here we have a matrix. Hold on. Let me change the dimensions. A 2 by 3 matrix. Go 1. Right, so here's a 2 by 3 matrix. And we're just going to move it inside here. Okay, so here it is. And, right, a matrix is made out of rows and columns. So what we'll have here is, hold on. Let's break this down into rows and columns. Right up here, all of this, these are columns, the vertical, right? The ones are in one column, the twos are in one column, the threes are in a column, right? They're all in the same column. So basically what happens here is we have these as our rows and I think that's our columns. As our rows, we have them across, so they're going to be across like this, right? So we have, well, let me do it the other way, it's a little bit less confusing. Right, and here we have our ones, so ones. And we have, right, our row 1 and row 2. And basically, as I mentioned before, it's a 2 by 3 matrix. How do we determine if it's a 2 by 3 matrix, or how do we determine what it is, right? How is that done? Let me quickly demonstrate. Now, let me put a real matrix, like with sequences of numbers in them. Right, so not 6 to 1. 6 to 1. Let's say 5 to 3. Just a random matrix. What we're going to do here is we are going to have like this, and I can put the dimensions underneath, right? 2 by, well, I guess I can put, right, multiplication sign, but just remember, when you get further into algebra, that will not be, in some cases, that will not be allowed, but since there are no variables here, you can actually use just do a multiplication sign if you want. But 2 by 3 matrix, right? So a 2 by 3 matrix, we count the rows first by the columns, right? Which gets us 2 by 3, right? And the rows and columns are numbered a bit differently, right? On a coordinate plane, for example, right? If we want to count how high up a point is to figure out what's the Cartesian coordinate of it, right? We're going to count down from the origin, right? 0, 0 on a graph. We count up. On a matrix, right? This is the first row. That's the second row. You count down, right? So if you're to find row 1, column 3, for example, right? The columns are always counted outwards, but the rows are counted down. So this is actually row 1, not row 2, row 1. And row 1, column 3, we go here, 1. 1 is what you'll get. So that's how you find the dimensions of a matrix. Now, what do matrices actually mean? I mean, what do you use them for, right? So this matrix actually represents an equation. What we're going to do here is learn. We have 6x plus 6y equals 1. I mean, it's 2y equals 1. And this is what the matrices represent. Right? So the first row and the second row. Right? So here we have the two equations. And what we're going to do is solve for it, right? But this time we're not using the traditional methods. This time we're using the matrix methods, right? So what we're going to do is isolate a variable. Let's start with x. So we have this matrix here, right? But we're not going to solve it using these equations as usual. Instead, we're going to use the matrix, right? So for example, these are different matrix operations, right? You can do R1, right? In the last video, I used symbols like these. If you aren't familiar with what symbols I use, go back and watch my last video on intro to linear equations, even though I actually did an intro and a more advanced, I went through the whole topic in one video. Right, we have R1, R2, right? Row 1, row 2, right? And we can add them or we can subtract them. In this case, we want to isolate the variable, right? These both have 2. So that gives us a chance to eliminate the y coefficients and completely eliminate y. So what we're going to do is subtract R1 minus R2, and that gets us our new matrix, right? So hold on. In matrices, though, we don't put the semicolon and type out what the new value is. It's not how it works. So in matrices, what we'll do is actually we take an arrow, right? And we're going to create a new matrix using that new value we have. There we go. Right, we have our arrows here, right? So we put the new matrix right here. And what we're going to do here is we get to choose which one we're going to take off the matrix, basically. So, right, we have R1 minus R2. This whole new row here. So we have to have this replace something. So let's have it replace R1, for example. Right? This will be the new R1. The new R1 will be R1 minus R2. Now, what we're going to do is we basically subtract. Once we subtracted these two, we're left with basically the x value. So what we're going to do is we have the new matrix. So let me get that new matrix out. Right, check up your matrix. Let me just copy this one. It's easier. Right, and paste it here. So I'm going to eliminate the values in row 1 and put in the new values. So let's just do that. Right, we have R1 minus R2. Gets us 1, right? That 1 means we have x there, right? This 1 means the coefficient of x. We've eliminated y, so this row is going to be the next row, column, it's going to have 0 on top. And then the final one, right, we're subtracting these now. 1 minus 3, negative 2. So since this is a constant, not a coefficient, it's going to be just -2. So if we were to translate this whole thing, it's basically x equals -2. We solve for x. So you can do this if you'd like. X equals -2. Now we just substitute into the y. Actually, we don't substitute. In my bad. In matrices, substitution is not what we use. Instead, what we're going to do is we are going to eliminate the x values and then go ahead and take the y values, subtract, and get our next solution. So what we're going to do here is basically we're going to multiply R1, right? R1, row 1, right here, by 5, right? Multiplying this by 5 means, right, the coefficient of x will be 5. And here, the coefficient of x will be 5. So if we subtract them, we're completely eliminating that 5x, isolating the y so we can solve for it. So we have our x value here, and now we're going to solve for our y value. Okay, so what we're going to do is multiply our 1 by 4, multiply 5. Right, so we have R1. Right, multiplied by 5. I was having some trouble with the arrow, so I'm just going to copy this one. And we're going to replace the R1 in this new matrix, right? We're going to replace it once again. Oops. This R1 times 5. And then this is our new R1. What we're going to do is go even lower and perform yet another matrix operation. Right, so let me just draw our new matrix. Right, so we have our new matrix. I will put these brackets around it, so like that. Okay, there we go. Have them here. Right, so oops. There we go. Alright, so our new matrix. So the row 2 has remained the same since the beginning. That's about to change. Right, so we have our matrix here. Once again, and we're going to and since we've multiplied our R1 by 5, what we have here is 5, right? 0 and -10, right? -10. And what we're going to do here is subtract. So we're going to subtract both values, right? We have 5x here and 5x here, and we're going to subtract them. Right, so let's go down. And subtract them. Or if you don't want to deal with negatives, it will be easier to do R2 minus R1. So let's stick with that. Try to avoid as many negative numbers as possible. So what we're going to do here is basically we have our two numbers here, and we are going to move them so that Here we go. And boom. Right, so we have our R2 and R1, and what we're going to do is we're going to move it to, either one's fine. I mean, at this point, we're solving the final bit of the whole thing. So R2 minus R1, right? We can always do that. And that'll get us 2y, right? That equals 13. Right? So y equals 6.5, right? We have our final solution here, and we have the first part. So basically, what we did here is found the place where the two linear equations intersect, where, right, we have 6y plus 2y equals, plus 6x plus 2y equals 1, 5x plus 2y equals 3, right? We have both of them here. And what we're going to, and basically what we found out is they intersect at point that's where they intersect. We've just solved yet another simultaneous linear equation using a completely different method. Right? We used a matrix instead of working it out with the equations. Right? So this is how you can solve these equations using a matrix rather than other alternative methods. Next video, we are doing determinants, right? Getting into that algebra 2 stuff, and algebra 1. I mean, still part of algebra 1, right? With the, determinants of matrices, and we're going to get deeper into matrices. And then the next video, my special video on the golden ratio. Okay. I'm Joshua Lyons, and this is Quick Math.